Hi, my name is Brian de Smale. I'm a co-founder of Simon & Konica, and I'm one of the hosts of our podcast, Talking Event Driven. I'll briefly introduce myself. I've been working with event-driven concepts and environments for quite some time now, initially as an engineer developer, and I gradually became an architect. Today I take to heart most of the technical subjects within Simon & Konica. I believe that event-driven approaches can offer incredible flexibility and revolutionize the way we design IT systems, and that's why we have this podcast about it. Today I'll be having a conversation with Anatoly Zelenin, a Kafka Trainer and the author of the German Kafka Book. We met Anatoly a while back when we had a conversation about his open source project called Kafka Backup, and it immediately felt right to have him on as a guest on one of our podcasts. We'll be talking about his experience with Kafka as a trainer and as a consultant in event-driven environments for his customers, but also about his open source project and how it worked out. I hope you enjoy this session, and I hope you'll gain some interesting new insights. Have fun.
Welcome to Talking Event Driven, the podcast about the world of event-driven architecture. You will hear seasoned professionals sharing invaluable insights about their challenges and experiences in event-driven architecture.
All right. Welcome to Talking Event Driven. With me today I have Anatoly Zelenin. He's a Kafka trainer and author of the German Kafka Book. But I'm sure you're better at introducing yourself than I am at introducing you. So go ahead, I would say.
Okay, thank you. Thanks for having me here, Brian. So yeah, I'm Anatoly. I do Kafka, I think, since 2018, when I've been a freelancer. So for Kafka terms, I think this is probably already quite a long time. And at some point, I read a lot of stuff of Kafka. I thought, yeah, why not sharing my knowledge that I have and sharing my experience, what I have. And in the mid of 2019, I decided, let's try to become a trainer. So my first customer actually reached out to me because they asked me on a conference whether I wanted to talk about Kafka and whether I want to do a training. And I said, yeah, why not? I am already planning to do that. And since then, I'm a full-time Kafka trainer.
All right. So you basically came from the consulting side to
Exactly.
Classroom trainings then, or specifically for the customers then?
Specifically for the customers, so I started with private trainings, but then broadened my perspective also to public trainings where I do it with different customers and together in classrooms, etc. And then, of course, as every story goes, today and then COVID happened.
Yeah. So that's when you wrote the book or not?
No, actually, we started writing the book, I think also 2020. Yeah, actually, this was the time when COVID happened. We started writing the book and released it, I think, 2021, if I remember it correctly.
All right. So it's a COVID baby in a certain sense.
But by accident. So I think it didn't have anything to do with COVID. But yeah, the timing was right at the time.
All right. Yeah, and as you know, the name of the podcast is Talking Event Driven. Do you cover anything about event driven in your trainings about Kafka? Or are you focusing more on the technicals?
Can you even talk about Kafka without being event driven?
Well, I would argue no, but there's lots of people who use it just for transferring data from A to B without actually doing events. So
that's true. So probably these are the two. So these are also the two main use cases I see here. From the one side, the people who are, I would say, it's the big data use case. So the big data use case where you just want to get a huge amount of data from A to B, and then all the rest that are trying to do more or less event driven, depending on how far in the stack they are. So yeah,
true.
Of course, as soon as we talk about architecture, as soon as we talk about development, I, for myself, I like it much more to talk about the event-driven use cases of Kafka than about the big data approaches.
Yeah. So you also flowed into it from the event-driven setup then, from your consulting years and so on. Yeah.
Yes, definitely.
So which kind of things were the earliest concepts that were introduced around event-driven to you then?
So for me, I think my first encountering with Kafka was this famous blog post from Martin Kleppmann, turning the database inside out with Kafka and Apache Samza, but I think nobody even knows what Apache Samza was.
Yeah, I can imagine that. Yeah. All right. Interesting. And that was for a specific customer or more of a private interest at that point?
I think when I read the article, it was more out of a private interest. But then I come to the customer that wanted to move their architecture towards a more Kafka-centric, a more event-driven approach. And then I basically said, yeah, I've never worked together with Kafka, but I've read about the concepts and I know how it works internally. And the customer said, yes, this is exactly what we want. Come and join us.
All right, cool. And then the entire track got started. And the further you went into the rabbit hole?
Yes, then they threw me in the rabbit hole. The first time I just read books, whatever I could find about Kafka. There wasn't so much literature out there. And yeah, at some point I needed to decide, okay, I think I need to contribute to this community too.
Mm-hmm. Yeah. All right. Yeah, one distinction that we often make is the difference more or less between events and business events. So the way to structure it on a higher level. Did you ever see the two sides of that coin in a certain setup?
What do you mean by events and business events?
You could have events which are more of an application nature, technical nature, something was clicked, something, smaller scale, let's just say. IoT, for example, is one of those things.
Yeah.
But you can also have events which are specific to domains. So that's often a distinction if you look at events being used in a system, if it's on a smaller scale or a larger scale. So yeah, I don't know if you've touched the both of them or...
I would go even further, I think. I think you cannot distinguish between events and or technical events and business events. If you look at what happens in a Kafka, there's much more that happens. I think the most obvious thing is transferring state. Here is a topic where you put information about an object as it is today or as it is now. Here is the information I know about a customer. Here's the information I know about the articles in his shopping cart.
Mm-hmm.
These are, for me, states.
Yeah,
and you can say, this is
compacted topics.
Yes, you can put it in a compacted topic, but you don't need to. So you could even say, no, I care about the history of the states, and then I can look at the topic and see what happened over time. Or what changed over time.
Yeah, what changed? What happened is the hard part in that case.
Yes, because the advantage of this is you just need to look at the news. So if you care only about the news state, you just look at the newest one and you can use compaction. But the problem is you have no idea what changed. If you look at a certain state, you have no idea why this message was triggered. So you can go further and say, okay, maybe it's also too large. Maybe you want to reduce the size. So the next obvious step is to say, okay, I don't send states, I send deltas. And just put only the information what changed in this topic.
Yeah. So incremental.
It has more semantics.
Yeah.
It has more semantics. It has a meaning. You now know not just somebody put something in topic, but you know, okay, something changed and this changed. But still you have no idea why it changed. And this is, I think, only then we come to the realm of states, of events, and where we say, okay, we describe a business event.
Yeah.
I don't know. IoT
describe
device was
behavior
installed.
in essence. Yeah. you describe behavior instead of state. So you started from actual state to changes in state, and then you made the step, okay, I'm going to record what actually happened, behavior in that sense.
And it's a business event. Of course, you can combine them. I recommend customers to put also some state or some delta information into the event to make it simpler. Because if you just have the information, something happened, it doesn't make so much sense if you want to put it in a database, for example. And on the other side, you have, of course, also the technical events, the measurements you take. Of course, you can say, okay, this is more like a state. The current temperature is a state.
Yeah.
And of course, you can also say, yeah, there's something more missing. What about requests? I would like you to do. Or what about a command? Please send a newsletter. Please send an email. Please send an SMS. Please send a push notification. And I don't think you can say you should use Kafka only for one of these. But you have always a combination of that.
True.
So my example I like to use is if you are, if you are a company that wants to send greeting postcards to people that married, then you can say, okay, if you use a state, you just have the information, person, ID, email address, name, marital status, but you have no idea whether the marriage just happened or what happened. Of course, you can use a delta, but then maybe somebody did a mistake when they entered the data, and then you will send a postcard to a person just married who is already married for 20 years and have currently a marriage crisis and think about breakups.
Yeah,
it's not good. But then you can say, okay, we have an event, we send an event, okay, just married, or a marriage status changed, and then you have a service that watches for that, and then triggers a new event, which is then send a postcard. And this will be a command.
It's dual what we normally do. So it's in the sense that you can send a command and then you get an actual event for it actually being done. So like, I want you to send a card and I've sent the card. So you have the two in that case. Huh?
Yeah, exactly.
Yeah. All right. That's pretty much how we also tackle it often. One of the challenges, for example, in that IoT use case, I don't know if you've had a lot of touch with those, but they constantly send states. But the question is always, and how do I turn this into events? What is an event for IoT data? I don't know if you've touched any of that in the past.
Sometimes, but not as often, because this is for me, IoT. If you talk about IoT, you are quite often in the big data use case where you just want to get huge amounts of data from the IoT devices into whatever data system you have. And usually what I experience is that in these cases you want to do alerting, something like that. And then you look at some thresholds and create an alert event, or you look into changes of measurements and want to do alerts. How do you do that? Or which kinds of events do your customer have in the world of IoT?
Well, it's there's various things. So in manufacturing and so on, you get indeed the thresholds. Like if it's above a certain thing, then it's running hot, for example. That's a significant thing for like maintenance use cases. But there might as well be outlier detections. If you have things that are constantly going up and you want the trend line to be, if it goes across a certain thing, that it triggers something. So yeah, and those might even be significant business events in many cases. Yeah. But we've seen that mostly with manufacturing. I don't think in manufacturing and energy, but I don't think I have other use cases right now that I can think of. but yeah, for most of these things, as long as we're transferring state in a certain sense, like the temperature is like this, and you get a new one every 5 seconds, it's often not bad to lose something. But for example, transactions, that's a completely different story altogether. If you lose I transferred $50 to someone or 50 euros to someone, that's a pretty bad thing to happen in many cases.
But don't forget, in manufacturing, that might be also bad. So if you're in pharma and you lose your measurements for your temperature, you might need to destroy the whole batch.
Yeah, correct.
And this costs
if there's requirements for that, yes.
Yeah. But you wanted to go into finance, I think, or it seemed to me.
Not necessarily, but yeah. And do you have a lot of experience in the finance side, the transaction parts?
So I think finance is where most of my customers, or not most of my customers, but maybe quite a large portion of my customers are in the finance sector. And even if you have quite old and conservative companies, banks, sometimes they are the first to say, yeah, this Kafka thing you're talking about, that might be actually useful for us. Even though it's a bank which is usually saying no to every new technology, they suddenly say, oh, what is that? That might be useful for us.
All right. What's the common drivers for that? Because they are also the biggest users of batch systems and everything else. So what drives that for them?
We, as customers, you don't want to wait a month for your credit card statement.
Yeah, true.
You want to use banking on your smartphone. You want to get notified whenever a credit card transaction happens. You want to be able to send money instantly, even across countries. And I think these are things that drives the change in these institutions, or even their own not customers, but employees that want to have a nice dashboard and want to have a real-time look at their customers and say, yeah, you have so much money on your bank account. Why didn't you want to think about this and that product, whatever?
Okay. So they're also experiencing the same stress a lot of the other businesses are experiencing with.
Definitely. So they experience the stress of getting into the 21st century. Yeah,
but they're also the carriers of a lot of legacy systems and so on. So it's often a challenge. How do we connect all of those? Because they are often master of a lot of these entities that you need to actually perform that part of the business. So that's usually a challenge.
It's very challenging, especially if your bank is still on mainframes, and you want to add real-time use cases to that one and want to enable your mobile applications. Then IBM will be very happy to charge you that money. But your bosses are not happy to throw even more money at IBM. So this is what I experience a lot. Experience a lot that many banks, they cannot and they don't want to get rid of core banking systems. It's not about that, but they want to add more value to the data in it, and they want to reduce the load on the core banking such that they can do new stuff, provide new business values to their shareholders, to their customers, to whoever they think about. And one of the approaches is basically, let's connect to the database of the core banking system, extract everything we have there into a more modern system like Kafka, and from there think about what we can do with the data. Because every access in a core banking system or on a mainframe costs you money.
Yeah, CPU cycles, the more money.
Yeah, and if you have your core banking system based on a huge Oracle database and it's running hot, you don't want to add your real-time applications to that one. So this is what often see in banking, or not only in banking, everybody who's using core systems, not core banking, not always mainframes, but even a supermarket has often a core system somewhere on a mainframe or in a huge Oracle database, and they don't want to get rid of it, but they want to add business value to that.
Yeah. So Edge, Kafka's point of sale setups, all these kind of things. Yeah.
Not even that far. Just
Mm-hmm.
just relieving the data from the core system and give other users in the company access to the data.
Mm-hmm.
Basically
All right.
freeing the data from the core, and then having your usual fan out where you say, okay, you don't have one piece of data is not accessed once, but twice, thrice, or much more often, which would be not impossible, but very hard in your classical core system. And then with Kafka, it's basically free. Once you move the data out of this legacy system into Kafka, you can access it basically for free. And then people are also thinking, yeah, okay, now we have the data in Kafka. How long can we store it there? It might be even interesting to store it forever in Kafka, because the price of running a Kafka compared to the development time and the money it costs to run your core system is negligible. Often.
Yeah.
Not always, but often.
Well, it's gotten even better with the offloading part. That's part of open source Kafka nowadays. So you can
that tiered storage.
literally use it for infinite storage.
I believe this changes everything about the calculation of Kafka.
Yeah.
Before tiered storage, Kafka is just a very expensive storage system.
Yeah, disks. So for small volumes,
not only
sure.
disks, but fast disks.
Yeah.
And the replication you have.
Yeah.
So basically you're paying, and there's no distinction, or in classical Kafka you don't have a distinction between storage and compute. So for every terabyte more you want to add, you basically also need to add linearly more compute to it, usually.
Yeah.
Because at some point you cannot just put more disks into your servers. And with tiered storage you can just say, okay, let's put the old data to AWS S3, to my FTP server, to my ZAN system, and don't pay the compute part of it, and don't pay the premium for your high performance SSDs, but just normal disk prices.
Yeah. Yeah, it opens the door for a lot of data retention use cases. Basically, you started with the book, turn the database inside out, but if you enable this kind of setup, then it basically becomes a database. You can keep your data in there forever. You don't need the database anymore. It's more or less you use the databases to project data in that case.
Yes, I think you can say this to people that know what you're saying, but to outsiders, I think this is you should be very careful about saying that Kafka is a database, or that you can get rid of your database. It's not the case.
No, but the function changes.
The function changes, exactly.
The function of your database. So you can't query a Kafka.
You don't want to query a Kafka.
You don't want to, you can, but you shouldn't. But the role of your database is no longer kind of the state of a record. It's more or less the place where you go to search for it, to leverage it, to project it to specific use cases. I want a specific projection around that, and I want it in say an Elasticsearch on one end, and I want it in a referential database on another end. Yeah, all those are possible then.
Definitely. So it gives you basically more freedom to choose technology.
Yeah.
And use the right technology, whatever this is, for your use cases.
Yeah,
I think
exactly.
this is also what Martin Kleppmann, the blog post is from 2015. It's old. And
the man was a visionary.
He is, hopefully, still.
Yeah. But he was already back then.
Yeah.
Yeah, it's certainly true. But it also changes the role of the Kafka. Eh? It's often, let's just say, considered on par in many organizations. Like, okay, it's an evolution of MyMQ. It's used to transfer data, but as soon as you turn it into it's actually gonna retain data, it also changes the entire role of the Kafka. So yeah.
And then
Those are
thinking about what is the value of the data in Kafka. If you lose your MQ, it's bad, very, very bad. And a lot of people will be annoyed about this. And you will probably lose, depending on the size of your organization, millions of dollars.
Mm-hmm.
But if you lose your core data system, whether this is your central Oracle database or your Kafka or whatever you use, this is not just a few $1 million it costs. This is basically your business is done.
Yeah, if you're running on a data-driven business, which basically everything is nowadays, it's like losing your database. You come in the morning and nothing's possible anymore.
Yeah.
So yeah, that's bad. I guess that's also why you created the backup solution on GitHub a while back and open sourced it.
Yes, this was exactly the idea. So I think to this day, there's no good story about disaster recovery for older data or for... Of course, you have the replication in Kafka.
Mm-hmm.
But replication, it's like saying, I have a RAID. Why do I need backups if I have a RAID system? Even in the 90s. Yeah, we already knew back then that a RAID system does never replace proper backup.
No, it's the constant story of high availability against actual disaster recovery.
Yeah.
And I think that's a common theme in the entire Kafka space. There's lots of options for increasing your reliability and high availability.
But
think
not
about
disaster recovery.
Yeah, but there's little or nothing in the Kafka platforms themselves to safeguard your data in case you just do a boo-boo, let's just say.
Yeah. And that's why back then I created this Kafka backup solution, even though it never went into production. And I'm quite sad about this one. Yeah, but this is as many open source side projects go. You start something, tinkering on it, and then business calls and says, yeah, and how do you actually earn money with that? And then you forget about it, or you say, yeah, I will do that later, and that's exactly what happened to Kafka Backup. But nowadays, with tiered storage, the need for backup in Kafka changes. It doesn't disappear, but it changes, because the problem with the good thing about tiered storage is, as soon as you have your data in the cold storage, it's easy to do backups, because you do backups as you do it always in your system of choice. Whether it's S3 and you say, okay, I trust AWS, or you just mirror it to, I don't know, Cloudflare, or to your local data center, or it's a SAN system in your data center, you know how to do the backup. You know how to move the data to your tape storage, for example,
copying
or
files
whatever you know.
in essence, yeah.
Yeah. But what about the data that lives in Kafka and is not yet in the cold storage? It's not a lot of data?
It depends, eh? You can set the properties how much you want to be hot, eh? Because it's also related to the latency use cases and everything else, eh? So
yeah, but
you'll always lose some data if you only back up the tiered storage.
Yeah, because as far as I understand, the tiered storage just starts working after you complete a segment.
Yeah.
And the segment
even
is
then
either
you
1
can
gigabyte or 7 days, whatever comes first.
Yeah, with the standard configuration.
With the standard configuration.
And you can even, I think, specify how long it should stay in your hot cluster as well.
Yes, additionally, but
Yeah.
it should be copied immediately after the segment is completed.
Yeah.
And then additionally to that, you can say how long it should store. So basically, the need for backup in a tiered storage scenario changes to the time the segment lives only on your Kafka broker.
Yes. But that in itself also complicates it further. Because if you actually need to restore, you need to know, like, okay, what do I have? What do I not have? How do I need to bring it together? So
yeah,
it complicates things and it simplifies things, let's just say.
and
And
you basically
another
need to
thing is
know,
that-
okay, if things break, what should you do? And it's always
Yeah.
the case. It's basically a business decision. So, for example, I had a customer that said, I don't care about Kafka backups at all, because if we lose the data in Kafka and it's gone and we would need to go to the backups, I can close my company.
Yeah,
It's too late.
the recovery time objective is too small
Zero.
to have.
Yeah.
Yeah. Yeah. Yeah. Those are the tough cases.
Exactly.
Yeah. That's true. But yeah, there's also the granularity thing. You have the disasters, but you could just as well have one topic or some other thing happen where you want the granular control more or less.
Let's delete the topic because I don't need it anymore. Oops, this was not development, it was a production environment.
Yeah.
And no matter how much replication you have, will save you from that one.
Yeah.
Maybe
That's
with Mirror Maker, you might be safe from this one,
Depends.
but depends on your configuration.
And oftentimes, if the infrastructure as code, for example, is in place and you make a small mistake, it could decide that it needs to re-provision that topic, and then it does it on all your environments and everything's gone.
Yeah.
So yeah, those things happen. That even happens to, let's say, your schema topic. Imagine that happening.
This is what I really don't like. So I need to say I'm not a big fan of the current approaches of schema management in Kafka. And there's one big reason for that, and these are the schema IDs. The schema IDs are just numbers that are incremented. There's no semantic meaning. You have no if you lose your schema topic, you have no chance, no way to ever restore the information in that one. And basically, if you are unlucky, you have no chance to ever read the data from your topics again, because you have no idea how the data looks like. So yeah,
Yes.
or at least it's a lot of work to make it correct.
Yeah, it's you have a sort of a tight coupling between the ID being created in your data and the schema registry. Without the two, it's a giant nightmare to get it back out.
Yeah. And the problem is not the ID, the problem is that it has no semantic meaning. For example, if the ID would be just a hash of your schema, then at least you would have a chance to generate, or it would be consistent. So if you mirror basically your schemas, you would have the same schema ID. But nowadays, if you delete a schema, for example, and recreate it, it will have a new ID. Or if you migrate, if you're in the cloud and use one of the cloud providers and migrate the schemas from one schema registry to another and just use Mirror Maker to migrate the data, and the target schema registry is stupid, let's say it will create new IDs, you must be very, very, very careful how to migrate the data from the one to the other, because as soon as you make one mistake, all your IDs are gone.
Then you need to look again at without the serializer or something similar to the old schema registry. So in theory you can map them. So if you know exactly what the schema IDs for your target are, and then you can map them and one-on-one do it through the Magic Byte setup. But that's a non-trivial task, let's just say. Yeah, true. Yeah, I've seen it happen once before. The oopsie with the schema registries. And that
I was lucky that I was not in the project anymore, but a friend of mine had the pleasure to migrate from one schema registry to another and thinking over the IDs.
Mm-hmm. Yeah. It's an effect of the schema registry, let's just say. There's I think, for example, the Red Hat schema registry does not encode the IDs. It keeps it completely outside. But that one has other challenges, let's just say, because you need another way to manage what schema is being used in which topic.
Okay.
Which
I
just
didn't
moves
work
out and
so much with Apicurio before, but it looks interesting. It looks good.
Mm-hmm. Yeah. Yeah, I understand that. It's sort of a bad practice to encode the IDs along with the data, but at the same time it gives you benefits, but yeah.
I don't think that the problem is the ID, but the lack of semantics.
Yeah, the lack of semantics and control on it, actually. Yeah. Yeah, true.
Okay.
Yeah, it's a common discussion subject, let's just say, the schemas. We come across it a lot. The same is true, for example, for the topic record naming. So to have multiple schemas in a single topic, that's another very polarizing discussion.
I believe.
All right, very interesting discussion, Anatoly. It was a pleasure to have you here, and I guess we can wrap it up for today then.
Yes, thank you for having me, and yes, see you soon, and latest think at the Kafka Summit next year in London.
Yes, we'll definitely be there.
Cool, then. Bye, Brian.
See ya.
Thanks for tuning in to another episode of Talking Event Driven. We hope you enjoyed the insights and stories shared by our incredible guests as much as we did. If you found value in today's discussion, don't forget to subscribe, rate, and leave us a review. Stay tuned for more enlightening conversations. Until next time, keep innovating and stay event-driven.